All right, so we are going to be talking about using similarity criteria. So if you remember last class, we did talk about 3 different types of similarity criteria, 3 different ways for us to figure out whether or not a triangle was similar. Those 3 different ways was AA similarity, we had SSS similarity, and then we had SAS similarity. Now, the purpose of using these right here is there's going to be some questions where you're going to have to figure out whether or not 2 shapes are similar first, or 2 triangles, are similar first, before you can actually use the properties of similarity. So, I feel like I've asked this at this point like 10 times. The 2 properties of similarity are what? Angles are what? Okay. Sides are what? Angles are congruent. Sides are proportional. Make sure you have that memorized. Now, looking at these questions right here, it says, Clarice is one of the surveyors hired to help determine land boundaries. She needs to find the distance across a ravine. She thinks she can use properties of similar triangles to find the distance. She located point A, B, C, and D, and E, and takes the measurements shown. So we have all of this information right here of these 2 triangles. And essentially what we have is she wants to find this length right here, this AB, right across the ravine. But she does not have the tools for it, I guess, or whatever. So for this one, it says, make sense of the problem. Which similarity criteria, if any, can be used to show that triangle ABC is similar to triangle DEC? So before you can even start using this property right here about sides being proportional, we have to figure out whether or not this one is similar. So just by looking at the picture, one of the first things that I see is there is a vertical angle right here. So that right here would give me my first A. So we're going to go ahead and write that down. So we have this angle right over here. This angle right over here, that's 61. And I know that this one over here is also going to be 61 degrees. Now, I know those are congruent because they are vertical angles. So we're going to just go ahead and write that down. So I know that angle, and the name for this one right here. Let me see if I can highlight it really quick. I know the name for this one right here is going to be ECD. So I know this one, ECD, is congruent to this other angle over here on the right. And this one, the name for it would be ACB or BCA, whichever way you want to write it. So ACB. Okay. And that right there gives us our first angle. Now, to get the other angle, or we can go ahead and compare their sides, right? We can do SAS maybe. But if you look right there, notice I have this side, but I don't have this side to do SAS. And same thing on the other side. I have this side right here, but I don't have any other information for that other missing side. So let's just take a look at the angles. So one of the things that we looked at with triangles, and hopefully we remember, is the angles inside of a triangle add up to what? The angles inside of a triangle add up to 180 degrees. So if I want to find this missing angles right here, okay, any of them, I can subtract by 180. So that's what I'm going to do. I'm going to go ahead and find this missing angle E right here. And I'm going to do that by taking that 180 and subtracting it by the angles that I have already. So I have that 61 and I have that 64. Okay, and we're going to go ahead and subtract it. So we're going to take 180 minus 61 minus 64. And that gives me an answer of 55 degrees. Okay, so I know that this angle E right here is going to be 55 degrees. So we're going to write that down right there. All right, Now that I did that, you should hopefully be able to see that now I have a couple of angles that are the same. So if I look right there, I see that this 55 degrees is the same as this one, and that gives me the second A. Okay? So I have this angle E is congruent to angle B because they're both 55 degrees.